Okay, I'm working on my new rivet machine here. It's not too late, is it? That ain't noon either. So, this is what I've got done so far. Got me a mounting plate mounted up under here. I got me some new die sets up here made up. So what we're going to do is we're going to redo these kicker ratchet gears in these Sportster baskets. I did this one a few videos back and I wasn't very happy with it. It's pretty crappy looking job. The rivets all folded over to one side because when I'm in a hydraulic press right here working, there's nothing to keep anything from moving around. So the rivet just lays over the side and smashes down. Looks like crap. So not happy at all. It'll work just fine, but this looks like crap. So I went ahead and bought this big Greenlee tool here. It's about a $6,000 tool. I got it on eBay, so I didn't pay into that for it. Luckily. Of course, it's not made for doing anything I want to do. So this stuff is all precisionally machined here. Damn. There it goes. Precision fit. So I've been working on this stuff all night here. So basically, this was an Allen bolt. Yeah, looks like one of those. More specific, one of these. Yeah, that's what it was. So, that's what we started as, and this is what we finished as. Pretty close. Only a little bit of machining, and we have a bushing. So, there's our table up here. Precision, well, not quite that precision. A couple thou clears. Anyway, this was a hex bolt. Kind of looked like one of those right there. So we turn the head down. The stock, these are the stock tools that come with it here. This is tools made for knocking out big electric box, holes like in big three-phase boxes. So anyway, that's the number of the damn thing. So anybody get any tooling for this, I could use it. So I only got these two pieces here, which I'm not using. So this is basically my hex head bolt here. I turn it down, and I got this plate made up here, and this I turn it down to fit into here. And it sits on the surface right here. So when you push down on this thing, it has a porta power pump right here that has a big hydraulic ram in here. And I'm not sure how much pressure it makes, but a lot. So this is our plate. Let's see, crappy side is up. It's flatter. So that just sits on there like that. So sits good and flat. Now when you put pressure on this, it's going to push it right in the center, not off the side. So you don't have to mount this. So then I got the hole up in here, which is heat treated, so I can't drill it or tap it or anything to hold anything. So that means when you make parts, you just have to make them really precision. So precision. This here's a rivet tool, which looked like one of these over here. And there was the other one I had. Another one floating around here someplace. Yeah, it's basically looked like this when I started. Oh, here it is over here. Here's its pin right there. So that's what it looked like before I turned it down. This one here, somebody ground it off on both sides. I didn't do that yet. So that's the rivet, the radius for the rivet on the end of it there. So that basic is going to give us a nice rounded head like this is right here when you push on it. So it'll also, when the rivet's way up here, it'll also keep it from walking around because it's going to recess into here. If you just pushed on it flat with like just a solid ram, the rivet can still jump around a little bit on you. If you're holding it like this would do on center, it's just going to mash straight down. It should give us a real good fit and finish. So anyway, this one here I machined it down. This is made for like a what are those damn hammer things? Rivet machines, not rivet machines. Air hammers. Yeah, I get the right words. So this was an air hammer tool, and I just cut all the stuff away, made it flat, turn it down. cut the length. There's a screw up inside of here, so that holds the ram all together up in here. So we can only go in there an inch. So I made this, so another precision fit. So stays put. There's no play, as you can see. It stays put. And obviously this bolt's not going anywhere. The table's not moving. So everything's pretty well centered up. This here is a Harley clutch spring out of a panhead, knucklehead. These are heavy duty springs. These are for the 67 earlier bike. So that goes right there. Basically what that does is it does this thing right here. So what it does is before you rivet the part down, it pushes it flat. So like this here, this one here is doing it flat. Need two hands. So when you want to rivet something, you want to make sure this plate is hard against the surface before you engage the rivet. Before, I never had any way of doing it. So what we got here is you got a spring. As you compress this down, before the rivet gets to it, it'll actually push this plate against the basket, and then it'll rivet it flat. So whatever tension spring you got, is how many hundreds of pounds of pressure you're putting on this thing. So that makes it nice and flat where it belongs. I also have a little centering tool that keeps it centered too. So that stuff I'm not using. So this one here, I'm going to make my own with a clutch spring. And then the rivet will be here. Now I'm not sure how tall the rivet's going to be, but it's going to be probably about this tall. A better picture here. So this spring's going to wind up being down here, probably a good ½ inch down like this. So I'm going to make me an aluminum spacer to go right up in here to take up the slack. And then I'll have to bend the spring slightly so it's holding down here, or I'll tie it up somehow. So we'll figure out how that's going to happen. And anyway, so once the basket's in there, which would be right here, we can come in here and just rivet this thing right on down, and the spring will be right here pushing on it. I'll probably also have to make a little bushing in the spring to compensate for the teeth here, because I don't want to push on the spring sideways like it's going to right now. So I'll make me a little 3/4 bushing that will be the same height as this, but it'll be cut out for this, so it'll have a little key cut in it. So I'm going to make a couple different things to make that right. So that should make it all right. Now we're running out of room here in my tool because I got too much crap in here. This was a pretty good size, pretty big tool I thought, but it's like most things, you run out of room real quick. So we only got ourselves a little extra space here, which is pretty much the height of the rivet, I bet. So if I need more room than this, I'm going to have to go up here and shorten my bushing up here, shorten this up a little bit or whatever. I got to gain some length someplace. I can't shorten this because that's pre-made. The next thing is I got to make something go on the inside of this to support the basket and to support the rivets in here. So I'm going to get this chunk of metal here. I'm going to go ahead and put that on there, and I'll bore it out so it fits around that seal and also sits on top of all the rivets. And then when it's upside down, I'll have a dowel, which would be one of these two down here, inside of the plate, in this thing here, which will hold it off the center on the plate, so it'll be where it belongs. So that way I'll be exactly on the center line of the rivet where I want it to be. Now this here is going to have to be exactly the right height for the basket, so I'll probably have to do a little bit, have shims available to play around with a little bit. And to make this rivet here, I'll probably wind up just using a dowel and machine it to the shape I want, and it'll just hold this in there flat. I don't know if I'm going to use the 5/16 right here, or I'm going to use the 3/8. I haven't decided which one it's going to be yet, but it's going to be one of these ones here. So the 5/16 will probably be a better fit, because you don't want to be pushing on the steel basket, you want to be pushing on the rivet head. So if you're going to push on the rivet head, you're going to have to be smaller than what the hole is right here, the countersink. It doesn't want to focus in very good, does it? That's kind of weird. Oh, I had my finger on the zoom button by mistake. Alright, so this is going to be kind of a, I have to figure out how I'm going to do this. And so I'm going to have to wind up coming in here, and I'm going to have to put a hole in here and recess this dowel into here, and have it only sticking up about 20 or 30 thousandths higher than the surface of all this other stuff here. So that way it'll make pressure on this. It'll probably be within 10 or 15 thou of the surface, I bet, when I'm done. So I got to make this still yet. The other thing is I got to make sure I offset this so that the center line will be on the rivet. So I'm going to have to come over whatever distance this is off the center, which is roughly, let's see here, that's about, looks like about 1 1/4 maybe. Flip over the thousandths number. So this would be 1 1/4 where my finger is. So about 1 1/4 off center it looks like. I'll do a little better measurement of that. And I'll go ahead and take this here, and I'll have a dowel hole here that goes into my bolt under the plate here. And then I'll move this thing over 1 1/4 inches and put the dowel right there. And that will take, I'll put a dowel through this here. So you'll have something like this sticking up right there. So when you drop this down on top, it'll dowel in exactly off center where you need to be, and this will be on center to here. So that's how you compensate for your 1 1/4 off center. That way everything stays put on center line where you want it to be. And all I got to do the baskets, I just got to rotate it one at a time, pop it, rotate it, pop it, rotate it, pop it. It'll self-align itself on top, because as long as you're on center line, everything works. So anyway, I got to mix more of these tools yet. Still got to figure out how I'm going to do exactly things, but so I think I'm going to just take my bolt here, which is basically something like this, and I'll just bore, drill it, ream it, put the dowel through that, and then it'll go through this, and that'll center it. Originally I was going to put a dowel on my plate, but I don't need to do it on my plate. I can come off the center lines here, and I can always change out these bolts because I happen to have more of them. So if you need to put a different hole in or whatever, different size that dowel, you just change out the bolt and you're still good to go. You're not affecting your plate because you want to keep your plate as solid as you can, so don't have any issues. So, but anyway, that's where we're at on this. So we're just kind of plugging our way on it. So this stand here was an old mixer I had, the paint mixing machine. I had two. This is for 1 gallons. I have the 5 gallon version. This is the 1 gallon version. So I gutted it, took all the mixing crap out. It makes a bitchin' stand. And it's really, really strong, but it's fairly lightweight because it's all cast iron, but it's casted, so it's only what you have. So you got yourself a 25, 30 pound piece at most. So steel plate adapts it to this. It ain't going anywhere. And it's comfortable table height here, so everything looks good. So I'm going to use a two-speed ram, not 2 pressure, 2 speed, and I'll get a gauge on it. So I'm going to have to spend about $400 or $500 to get what I want. This is just a cheap quarter power one here. I don't have any control of the pressure except just by feel. When I put a gauge on it, I will be able to control my pressure of when I'm riveting, really real fine adjustment. It'll be like my press over here. We got 2-stage rams, so you got a high-speed ram. See where it moves real fast. That's high speed, low pressure. Then you flip the valve here, and this is low pressure, but it's more like low volume. It's really high pressure on the ram. See, the ram doesn't move very much now for all your cranking, but it puts out a lot of pressure. So that gives you an idea where you're at. So because this here, I can put about 5 tons of pressure on the first stage, and then on the other one here, I've had it up to 50 before, 50 ton, but it's only rated for 40. So yeah, your machine flexes a little bit. But anyway, it gives you a good feel, because I got really good feel in my press here, so I know when I'm trying to break something, I can feel it. So I want that same effect over here when I'm doing the rivets, so I get a nice good rivet, and not make it so hard that you start splitting the heat-treated pieces here or other things. This is fairly strong, but other stuff you rivet, like brake shoes and things like that, and brake drums, because I also want to be able to do brake drums like these over here. So these are these are steel, so it's hard to hurt them. These are cast iron, which you can obviously crack these when you put too much pressure on them. So this one's pretty thick, so it's not a problem. This is a sportster variation here, and these are thin lip, and they break pretty easy. So I'm going to wind up making tooling for doing all these different brake drums. So we got sportster, we got knucklehead, we got the early 60s pan, and we got the later 60s shovelhead drums. So we'll be able to re-rivet all these and have the same precision rivet like this would be, where you got a nice dimpled head on it, or this is a raised head, and have it a good straight and on center and a tight rivet. So anyway, that's where we're at on this. Another day wasted doing this, but oh well. least we have a good machine when we're done.